Hello all, my name is Rakesh Bhaiya, currently studying in Sri Venkateswara College of Engineering in Computer Science and Engineering 8th semester. And today I am going to discuss about my technical seminar on explainable artificial intelligence application in cybersecurity and share my knowledge on it. Hope it will be informative and helpful to all. So let's jump to the contents and take a look at what we are going to discuss today. Coming to the table of contents, we are going to discuss about the introduction on how the artificial intelligence can be used for cybersecurity, about its history, methodology, issues of using artificial intelligence in cybersecurity, the results of it, applications, future enhancement, conclusions, and references from where I took the points. Coming to the introduction part, explainable artificial intelligence, also known as XAI, is a relatively new concept in the field of artificial intelligence that aims to make AI more transparent and understandable to humans. The goal of XAI is to create AI model that can explain their decisions and reasoning to human users in a way that is easy to understand. XAI has important applications in various domains, including healthcare, finance, and cybersecurity. In the cybersecurity domain, XAI can be used to develop more robust and effective security systems by enabling human analysts to better understand the behavior of AI models used for threat detection and responses. Coming to the history, the development of neural networks can be tracked back to the early 1940s when Warren McCloud and Walter Pitts published a paper on how to model the activity of neurons with mathematical functions. In the 1950s and 1960s, researchers developed perceptrons, which were the first neural networks capable of learning from data. However, in the late 1960s, it was shown that perceptrons were limited in their learning capabilities, and interest in neural networks declined. In the 1980s, new types of neural networks were developed, such as backpropagation networks and radial bias function networks. These networks allowed for more complex learning tasks and sparked renewed interest in neural networks. In the 1990s, support vector machines and other machine learning techniques began to challenge the dominance of neural networks, but neural networks continued to be studied and improved. With with the advent of big data and more powerful computing resources in the 21st century, neural networks have become even more important and have achieved significant success in many applications. Coming to the methodology, let's take a look at this flowchart. Let's suppose we need to publish a paper on certain website. So what we'll first do is we'll go to the search engine and we'll type the topic of the paper we want to publish. So the AI will basically identify the keywords from the topic and check whether the same paper was published from 2011 to 2022. If no, then then the process will be excluded. L, and if yes, it will check if it was in English language. Similarly, if the paper is in English language, then it will check if the paper is duplicate. If the paper is duplicate of the same paper, then the process will be excluded, else the paper will go to the categorization of selected references. From there, it will go for further review on different factors. So, how the AI artificial intelligence is used in cybersecurity. Literature review. The author conducted an extensive review of the existing literature on explainable artificial intelligence and cybersecurity to gain a better understanding of the current state of research in the area. Data collection. The author collected data from various sources such as academic journals, conference proceedings, and technical reports to identify relevant research studies on XCI in cybersecurity. Analysis. The collected data was analyzed using a systematic approach to identify key research themes, trends, and gaps in the literature. Framework development. Based on the analysis, the authors developed a conceptual framework for XI applications in cybersecurity that can guide for future research and development efforts in this area. Case studies. The author presented case studies to demonstrate the applications of XAI in cybersecurity. These case studies involve the use of XAI techniques such as decision tree, rule-based system, and neural networks to identify potential cybersecurity threats. Evaluation: the author evaluated the effectiveness of XAI in cybersecurity by comparing it to traditional cybersecurity techniques. The evaluation was based on factors such as accuracy, transparency, and interpretability. Overall, the methodology used in the paper was a comprehensive approach that combined literature review, data collection, analysis, framework development, case studies, and evaluation to provide a comprehensive overview of the current state of research on XAI in cybersecurity. Coming to the issues of using artificial intelligence in cybersecurity, lack of standardization. One of the major issues is the lack of standardization in the field of XAI, which can be led to inconsistency in the evaluation of different XAI systems. Interpretability versus accuracy trade-off. There is often a trade-off between interpretability and accuracy of an XAI system, as the most accurate models are often the least interpretable and vice versa. Scalability. XI system may not be scalable, particularly when dealing with large datasets or complex models. Human factors. XI systems must be designed with human factors in mind, such as the user's ability to understand an output and make decisions based on it. Security and privacy. XI systems may also pose security and privacy risks, particularly if they are used in sensitive applications such as finance or healthcare. Bias and fairness. XAI systems may be sustainable to bias and discrimination, particularly if the data used to train them is biased or incomplete. Validation and testing. There is a need for a standardized approach to validation and testing of XAI systems to ensure that they perform as expected and are safe from development in real-world application. Coming to the results of using artificial intelligence in cybersecurity, the identification of various XAI techniques and tools that have been used in cybersecurity, including decision trees, rule-based systems, fuzzy logic, neural networks, and Bayesian networks, among others. The author also discussed the potential benefits of XAI in cybersecurity, such as improved accuracy, transparency, and trustworthiness of AI systems, as well as better decision making and problem solving capabilities. One of the key findings of the paper is that XAI can significantly enhance the ability of cybersecurity analytics to detect and respond to cyber threats. For example, XAI can help in identifying anomalies, predicting attack patterns, and explaining the reasons behind certain actions and decisions taken by an AI system. However, the paper also highlights some of the challenges and limitations associated with the use of XAI in cybersecurity, such as the need for large amount of data, the difficulty of interpreting complex models, and the potential for bias and discriminations. The authors concluded by emphasizing the need for the research and development of XCI techniques and tools in cybersecurity. In order to address these challenges and fully leverage the potential benefits of XCI in this domain. Coming to the applications of artificial intelligence in cybersecurity, we can use this for intrusion detection. Explanations generated by XI techniques can be provided insight into why a system was compromised and can help identify patterns that are characteristics of malicious activities. Vulnerability assessment. XI can help identify vulnerabilities in a system and provide recommendation for remediation by identifying the root cause of a vulnerability. Malware detection. XCI can help identify whether a file or code is malicious and provide an explanation for why it was flagged as such. Forensic analysis. XCI can help in identifying the cause of a security breach by analyzing large amount of data and providing explanations for detected anomalies. Access control. XCI can be used to monitor access to sensitive data, and explain why certain actions were permitted or denied. Artificial intelligence in cybersecurity can also be used for security operations centers. XAI can be used to enhance the efficiency of security analytics by automating routine tasks and providing explanations for detected threats. Threat and intelligence. XAI can be used to identify new threats and provide an explanation of why a particular activity or pattern is considered malicious. Overall, XAI technique can help improve the accuracy and explainability of cybersecurity systems and can help security professionals make more informed decisions. Coming to the future enhancement of artificial intelligence in cybersecurity, development of novel XAI techniques. The paper suggests that further research in XAI should focus on developing novel techniques that can effectively explain the decision-making process of complex AI models in cybersecurity applications. Integration with existing cybersecurity tools. To maximize the effectiveness of XAI in cybersecurity, the paper suggests that further research should be focused on integrating XAI techniques with existing cybersecurity tools to enhance their accuracy and efficiency. Implementation in real-world scenarios. The paper highlights the need for testing XAI techniques in real-world cybersecurity scenarios to validate their effectiveness and ensure their practical abilities. Improved user understanding. Further research should also focus on developing user-friendly interfaces for XAI techniques to improve users' understanding and acceptance of these methods in cybersecurity applications. Addressing ethical concerns. As AI becomes more prevalent in cybersecurity, it is important to address ethical concerns related to data privacy, bias, and transparency. Further research should focus on developing XI techniques that are transparent and accountable, and they can ensure the ethical use of AI in cybersecurity. Coming to the conclusion, the paper presented a comprehensive review of the application of explainable AI in cybersecurity, highlighting the state of the art in research. The review found that explainable artificial intelligence had potential applications in various areas of cybersecurity, including intrusion detection, malware detection, and vulnerability assessment. The paper also identified some challenges and limitations in applying explainable artificial intelligence techniques, such as the need for larger and diverse dataset, the potential for adversarial attacks, and the trade-off between interpretability and performance. The review concluded that explainable artificial intelligence can play a significant role in enhancing the security of systems and networks by providing human understandable explanations for decisions made by AI models. The author recommended that further research in this area should focus on addressing the limitations of current explainable AI techniques and developing more robust and effective models for cybersecurity applications. So these are some of the papers from where I took the points on how the artificial intelligence can be used in AI security. If you want any further information on the topic, you can go through the references. So thank you. If you like the video, please like the video.